Okay, now we're going to do lesson 3.5, which is to use the distributive property to solve equations. Okay, and again, it's going to be linear equations because all chapter 3 is linear equations. Let's talk about what we've done so far. We've done lesson 3.1, which is to graph linear patterns that are either constant increases or constant decreases. We've done 3.2, which is to solve equations by reading tables and graphs. We skipped 3.3 because that's computer-assisted software. We did 3.4, which was if you have an equation in the form of ax plus b equals c, you can solve it by first getting rid of b and then getting rid of a. And then finally today we're going to talk about 3.5, which is to use the distributive property to get it into the form of ax plus b equals c so that we can then solve it. Okay, so the big idea is to say you can either collect like terms or you can expand expressions, and by doing that you can transform an equation into this form and solve for x. When you collect like terms or expand expressions, you are actually using the distributive property. Okay. Read carefully what your homework is for this lesson because I'm choosing specific problems to skip and specific parts of problems that I think would be easier or more helpful for you. Okay, first part of this is to collect like terms using the distributive property. Okay, so Miss Lovett is going to divide up her Twizzlers between several people. Her two parents, her three sisters, and you. Okay? And what you need to determine is how much each person gets. Now, this problem is actually adapted from one in your book, and it actually had to do with dividing money between people, but I thought we'd do this. It'd be more interesting. Okay? In any word problem, first step is figure out what you know. Second step is to figure out what you need to figure out. Okay? And after you know the information they're giving you and you know what it is you need to figure out, then you can go ahead and identify what each of those pieces of information are. Because something in there is going to be a constant, the thing that's not changing. Something in there is going to be a variable, the thing that is changing. Now it says here, only have one variable. If it has a situation like this where you have parents and sisters, you can adapt the variable so that it only has one, and it stands for both the parents and the sisters, and you'll see that in a second. So identify the constants, identify the variables, one variable, identify the coefficient, which is the thing that's how much the variable is varying by, and then identify the total. Okay, the total is one of the easy things to identify, and so is the constant. Okay, after you've identified what each of them are, just label them. Okay, label the constant b, label the variable x, or in this case you'll see we're going to label it p for parent to make sure we remember what that is. Label the coefficient as a, how much it's varying by, and label the total as c, so that you can set them up in the form of ax plus b equals c. Once you get it set up, the point of 3.5 is you may very well at times need to combine like terms if you have more than one c, or you may need to combine like terms if you have more than one situation for a variable like we're going to have here with the parents and the sisters. And once you get it all combined together, then you can solve for x like we did in the prior lesson. Okay, so here we have the specifics for this problem. Miss Lovett's dividing up her Twizzlers. We know that she has 2,600 packages. We know who she's dividing them up between. We know that her parents are getting an equal amount. We also know that her sisters are getting half as much each parent gets, and we know that we're going to get 150 packages, no matter how many the parents and sisters get. Okay, so that's what we know, and what we need to figure out is how much everyone gets. Okay, so now we take what we know and we need to figure out, and we identify them in math terms of a, b, x, and c. So the constant is 150, how much we're going to get. The variable is p, okay, and that stands for parent because, you know, parents are, one parent's going to get the same as much as the other parent, but the parent p also stands for the sisters, okay, not p and s. And the way we're going to make that p stand for both the parents and the sisters is by the coefficient. The coefficient for the parent's going to be 1, and the coefficient for the sister is going to be 1/2 or 0.5. So that allows us to have one variable and stand for both of those situations. And then the last thing to identify is the total, which is 2600. C is 2600. So now we've identified what we know, what we need to figure out, and we've put math terms on all of them, and we can write them pretty close to the form of AX plus B equals C. We have 1P plus 1P plus 1/2 P plus 1/2 P plus 1/2 P plus 150, the amount of Twizzlers we're getting, is equal to the total number of Twizzlers of 2600. Then we combine like terms, combine all those P's together, and we get 3 and 1/2 P plus 150 equals 2600. And like we did in the last lesson, we'll get rid of the 150 by subtracting it from both sides, and then get rid of the 3.5 by either multiplying by the reciprocal of 3 1/2 or dividing by 3.5. and just have P by itself. And then we'll know how much each parent's getting, and then with that we can figure out how much each sister's getting. Okay, the next part is the other aspect of the distributive property of removing parentheses. Okay, with the distributive property? Okay, this one doesn't have anything to do with the Twizzlers and Miss Lovett. It's just a straight equation that I took out of your textbook, and we want to solve for x by removing the parentheses. So we've written the equation 2 parentheses x plus 3 equals 7. First step, do the distributive property. 2 times x, 2x. 2 times 3, 6. So I have 2x plus 6 equals 7. I now have it in the form of ax plus b equals c. And I can do what we did in the prior lesson of getting rid of b by subtracting 6 from both sides, subtraction property of equality, and getting rid of a, okay, well first simplifying again, 2x equals 1. And then getting rid of a by, in this case, using the division property of equality and dividing both sides by 2. If a had been a fraction, you would have wanted to use the multiplicative inverse property and multiply both sides by the reciprocal and allow the a to go away by multiplying by its reciprocal. Okay, and then solve for x, which in this case is 1/2. All right, so back to Miss Lovett for a sec. So let's do another one. That was just an easy one to show you how it worked. Now let's use a more complicated one and talk about Miss Lovett and the Twizzlers. I also took this problem out of your book, but it actually had to do with a different delivery problem as far as renting a truck, but I just adapted to Miss Lovett and her Twizzlers to make it more fun. Okay, so Miss Lovett has these bunches and bunches of Twizzlers, and she decides she wants to take them to Jekyll Island with her, but she doesn't want to just put them in her car because she's got so many. Okay, so she goes to a special rent-a-truck place and says, I need a truck to take all these Twizzlers to Jekyll Island. They say, okay, fine. We've got this truck that rents for $29.95 a day, but the first 50 miles are going to be free. She's like, great. Okay, what about after that? Well, after that, we're going to charge you 60 cents per mile. She's like, okay. And so she goes ahead and she rents that truck and she drives to Jekyll Island. She ends up paying $100.15. All that information is the stuff that you know based on the problem in the book, and now I've adapted it to this one. What you need to figure out is how many miles did she drive? Did she get to Jekyll Island or not when she paid $100.15? Okay, so we now have what we know and we have what we need to figure out. Put those in math terms of A, B, X, and C. Well, this problem actually, I already gave it to you in terms of A, X, B, and C. It's pretty much right here, pretty close to it. Okay, so they told you the thing that's not varying. The not varying part is the $29.95. That's B. They told you the total, which is how much money she spent, $100.15, and that's C. Okay, they told you how much it's going to vary by, and that's 60 cents a mile. That's A. The thing that's a little bit complicated here is that the variable is not just M. M doesn't kick in until after the 50th mile. So the variable is actually M minus 50. That's when you start being charged the 60 cents. So as I said, it's a little bit more complicated, but they gave us the equation. Okay, so they identify, or we just identified A, B, X, and C. And we have this equation right here. And now we're just going to use the distributive property and solve for M. First thing we're going to do is distribute the 60 cents to the M and get 0.60 M. We're going to distribute the 60 cents to 50, okay, and get 30. 0.60 times 50 is 30, okay? So now we have 29.95 plus 0.60 M minus 30 equals 100.15. And then we're going to combine like terms. This 29.95 can be combined with this minus 30 and get minus 0.05. Okay, so we've combined like terms. That's the only like terms in that equation, so we're now at a form of AX plus a negative B equals C. Okay, and now we're going to solve for M, or X in the standard form. So we're going to add 0.05 to both sides of the equation, and we will end up with 0.60 M on the left-hand side and 100.20 on the right-hand side. And then we're going to divide both sides by A, which is 0.60, and we're going to end up with just M on the left-hand side and 167 on the right-hand side, which means that she drove 167 miles and did not quite make it to Jekyll Island. And that's 3-5.